All right, let's talk a little bit about parallel lines cut by a transversal. So what do parallel lines cut by a transversal even look like? And then they form different angles, and we're going to talk about the angles they form. So first, let's take a look. These are parallel lines right here. This line is parallel to that line, okay? And then it's cut by this line. It just goes through there. And whenever you have two parallel lines like this that are cut by a transversal by any line, doesn't really matter the angle of that line, then it forms certain angle pairs, and those angle pairs have very specific properties. So first let's take a look at what these angle pairs look like, and then we'll figure out what their properties are. So first, corresponding angles are ones that are on the same side of the transversal, and then they're both on top of the parallel line, like 2 and 6, or they're both on bottom of the parallel line, like 4 and 8. And you're going to see the same side on the same thing on the other side of the transversal. 1 and 5 are corresponding angles, and 3 and 7 are corresponding angles. So all of these are different corresponding angles to each other. So some examples are angles 1 and angle 5, angle 3 and angle 7, angle 2 and angle 6, and angle 4 and angle 8. Those are corresponding angles. All right, alternate interior angles. Now let's see what that really means. So here we've got our parallel lines. They're cut by a transversal. Alternate means that they're on opposite sides of the transversal. So if one of the angles is on this side, then the other angle is going to be on this side. So that's what alternate means. Now interior means that they are inside the parallel lines. Okay, so they're going to be in the middle of these two lines, not on the outside, on the inside, the interior. So alternate interior angles are going to be these ones here. So here's 3. If we go with 3, what angle is on the opposite side of the transversal? So we go to the other side of the transversal and still inside of these. Well, it's this one right here. Alternate interior angles are on opposite sides of the transversal, but still inside the parallel lines. And so that would make 5 and 4 alternate interior angles. Angle 3 and angle 6 and angle 5 and angle 4. Now these ones aren't alternate interior angles at all. They don't have a pair because they're outside of the parallel lines. So you got alternate exterior angles. So that's going to give us a little hint to what they are. Well, alternate means they're on opposite sides of the transversal. Exterior means they're on the outside of the parallel line. So instead of being in here, they're out here. So the alternate exterior pair would be 1 and 8. See, they're on opposite sides of the transversal, and they are outside of the lines, the parallel lines. So there we go. We have 1 and 8 and 2 and 7. So consecutive interior angles, and I want you to write same side interior angles. That's the other name for them, same side interior angles. So let's figure out what that would mean. Well, same side or consecutive means that they are on the same side of the transversal. So they're either the same side, both of them are on this side, or both of them are on this side. And then interior means they're inside the parallel lines. So that would make 4 and 6 same side interior angles because they are inside the parallel lines and on the same side of the transversal as each other. And then 3 and 5 are a pair of same side interior angles. Now these are two we talked about in another chapter, but let's review them again. So linear pair angles, a linear pair would be like 2 and 1 because they form a line see that it's a line. If you start on this line, you go all the way around, you end up on the line again. So 1 and 2 form a line. 3 and 4 also form a line. But guess what? 1 and 3 also form a line there. And 2 and 4. Also form a line. So there's lots of linear pairs there. Angle 1 and angle 2, angle 3 and angle 4, angle 1 and angle 3, angle 2 and angle 4. Now it would go the same down here, so angles 5 and angle 6, angle 5 and angle 7, angle 6 and angle 8, and angle 7 and angle 8. It's going to follow this same exact pattern down here. 5 and 6, 7 and 8 form a line, but then see if you turn it, you can see 7 and 5 also form a line. And 8 and 6 also form a line. All right, last one, vertical angles. So vertical angles are across from each other whenever you have intersecting lines. So this line intersects this line, and this angle is across from that angle. So those are vertical angles. This angle is across from that angle, so they are vertical angles. Down here we have this angle 6 is across from angle 7, so they're vertical angles. And 5 is across from 8, so they are vertical angles. So these are all the different pairs. Angle 1 and angle 2, angle, not angle 1 and angle 2, angle 1 and angle 4, angle 3 and angle 2, angle 5 and angle 8, and angle 7 and angle 6. So we have all these different kinds of angles, angle pairs, and there's some special relationships. If the lines are parallel, that's very important. If the lines are parallel, cut by a transversal, then you know some things about these angles. Now, if the lines are not parallel, you have no relationships, okay? But if the lines are parallel, you know something about all these different angles. Let's see, let's start down here. Vertical angles, we already know that these ones are congruent. And remember, that's just a math word for meaning equal. So 2 and 3 are congruent to each other, 1 and 4 are congruent to each other. So if the measure of angle 7 is 52 degrees, the measure of angle 6 is also 52 degrees. Okay? Linear pairs, well, let's think about this. They form a line, and a line is 180 degrees, so they can't be congruent. These guys are supplementary. Okay, which means they add up to 180 degrees. You can remember our little trick. If you write the word supplementary, you can see that it changes into 180 degrees. That's how you know that supplementary is the one that makes 180 degrees. All right, alternate exterior angles, just looking at them, you can kind of see that they almost look like vertical angles, just they're further apart. So these ones are also congruent. Again, meaning they are equal. Now, if you look at this one here, now if we know that 8 and 1 are equal, 8 and 1 are equal to each other. We also know that 8 and 5 are equal to each other, okay, because they're vertical. So that makes 5 and 1 equal to each other, right? If these two are equal, and these two are equal, then by the transitive property, these two are equal. Well, if these two and this one is equal, this one and this one are equal, these two are equal, then that means this one has to be equal to that one. So these are also congruent. Okay? So because these are equal and these are equal, that makes 5 and 1 equal. And because 4 and 1 are equal, and 5 and 1 are equal, we know 5 and 4 are equal. All right, corresponding angles, we just talked about how this can work, right? If 8 and 1 are equal, then 5 and 1 are equal. Well, 5 and 1 are corresponding angles, so these are congruent. And last but not least, consecutive or same side interior angles. If you look at these ones, if 8 and 5 are equal because they're vertical, and 8 and 6 make a line because they're a linear pair, you can see that, then wouldn't 6 and 5 make a linear pair? Okay, so we see that. Well, if 8 and 1, say this, if 8 and 1 are equal, and 8 and 5 are equal, well, 1 and 3 make a line, right? 1 and 3 make a line, we can see that. So 5 and 3 should also make a line, because this one here, number 1, is the same as 5. And if these two are equal, and these two make a line, then these two also make a line. So I know that's a little bit discombobulated. Let me just explain it one more time because that did not come out right. All right, so if we know 5 and 1 are equal because they're corresponding angles, these two are equal to each other. So if 1 and 3 make a line, well, 5 is the same measure as 1, so 3 and 5 will also make a line. So these ones are supplementary. So there you have it. There are your rules for all of the angle pairs formed by parallel lines cut by a transversal.